Okay, hello everybody. CozyAzeroth, aka Zachary Fruhling here. This is the second program from the TI-99 for a user's reference guide type-in programs. This one is called Inchworm, and I just did random color dots a few minutes ago. You can check out that video on YouTube if you missed it. Let me get TI Basic going. I just realized I forgot to open TI Basic, open the emulator. Let's get that going. There we go. Okay, TI Basic. So let's read all about the program we're going to type in here. Inchworm. This program creates an inchworm that moves back and forth across the screen. When the inchworm reaches the edge of the screen, an uh-oh sounds, and the inchworm turns around to go in the opposite direction. These statements allow you to enter a color for the inchworm. Color codes 2 to 3, 5 through 16 are recommended, 4 being the default background color for a running TI Basic program, that light green color. The screen is then cleared. The called color statement assigns the color you selected to the character set 2. XDIR is used to designate which direction the inchworm moves. +1 indicates right, and -1 indicates left. This loop moves the inchworm across the screen. Line 180 computes where the next block is to be displayed, and line 190 places the new block on the screen. The delay loop governs how fast the inchworm moves across the screen. Line 220 erases the old color block, so a continuous line won't be drawn, by placing a blank space over the block previously displayed at X old. Line 230 saves the current block position, so a new one can then be computed. The loop is repeated until the inchworm reaches the edge of the screen. Line 250 reverses the direction of the inchworm. Lines 260 and 270 produce the uh-oh sound. Then line 280 causes the loop to be performed again. Okay, let's go ahead and start typing, as they say. Okay. Let's see. Even though we don't need the remark statement, let's add the remark. 100 rem inchworm. I want to try to type these in exactly as they're written in the book for posterity. Okay, 110, call clear. $120, input color. Always a little space there, and I think we just called it C. Yep, C. I prefer longer variable names myself, but when computers' memory was at a premium, shorter variable names were the norm. Okay, 130, call clear. Clears the screen again. 140, call color. Okay, wait a minute here. Okay, is that a Z? I think it's a 2. Yeah, I think we just have a little line compression here. Yep, 2, C, C, I believe. Yeah, I'm pretty sure. That makes sense. We're going to use character group 2, C, C. Okay, line 150. Oops, 150. Excuse me one second, I'm going to close the door here for a little more quiet. Okay, so where were we? We were at line 150, X old equals 1. 160, that was just the laundry machine back there. XDIR equals 1, that sets it going to the right, to the X direction to the right by default. So XDIR equals 1. 170 for I equals 1 to 31. Okay. So that's one big 4 next loop lines, 170 to 240. So 180 x new equals x old plus xdir. And of course, if XDIR is -1, it just subtracts 1. Very clever. 190, call HCHAR. Now we're starting to draw some characters to the screen here. 190, call HCHAR. 12, comma X new, comma 42. $200 for delay equals 1 to 200. That's just a delay loop that gives it a little, leaves it on the screen for, I think, 200 milliseconds, if memory serves. 210, next delay. It's funny how the writers of these programs are not terribly consistent about whether you're using single letter variable names versus descriptive variable names. It's something that jumps out to me now. Okay, 220, call HCHAR. 12 X old, comma 32. Okay, 230 X old equals X new. And 240 next I. Okay. Then we change the direction. See, we take XDIR and make it the negative. So it was negative makes it positive, it's positive makes it negative. So 250 XDIR equals negative XDIR. XDIR equals negative XDIR. Changes the direction. Okay, then we play some sound. 260, call sound. $100, 392, comma 2. Okay, so that is 100 milliseconds. Frequency is 392, and the loudness is 2. That's the part of a O. And then 100, 330, comma 2. Oops. Typos abound. 100, 330, comma 2. There we go. And finally, 280, go to 170. Let's check our work real quick. This program is short enough where we can check it on the screen. Okay, we've got remark, inchworm, 110 call clear, 120 input color, syntax looks good. Aw. Susan is watching from her work towards the end of her workday. And I love you never hurts anyone. Love you too, my love. Just doing very short little retro streams here. Alright, so yes, checking the syntax of line 120, input, color, space, colon, will give that variable, that color number, the variable named C. Line 30, call clear. Line 40, call color. Character group 2, and foreground and background color are the same. 150 is just a variable, X old equals 1. 160, X direction equals 1. 170 for I equals 1 to 31. Let's just double check our, yep, I equals 1 to 31. I'm just making sure we didn't make any typos here. 180, X new equals X old plus XDIR. Positive if XDIR is 1, and subtracts 1 if XDIR is -1. 190, call HCHAR, 12, comma X new, comma 42. So row 12, column X new, so it changes the column, and then character 42, which is an asterisk in character group 2, I believe, which is why we use number 2 and call color up here. Okay, so 200 and lines 200 and line 210 are just a time delay. For delay equals 1 to 200, next delay, so 200 milliseconds. 220, call HCHAR. And of course, this is what overwrites the old. As the character moves, we have to delete the old square at the end of the inchworm. Okay, 230 X old equals X new. Okay, 240 next I. 250 XDIR equals negative XDIR. This changes the direction. And we have our two call sound statements of 280 go to 170. Just double check, 280 go to 170, and I think that should do it. Let's run the program and see what we get and enjoy the fruits of our labor. Color. I don't know, let's do what looks good on green. How about magenta 14? Okay, here's our little inchworm moving across the screen. Let's take a screenshot of this. And when it gets to the end, it'll play uh-oh and change direction if we did our work correctly. Doo-doo. Uh-oh. And it will do this ad infinitum until we end the program. We'll do it a couple times with a couple different colors. Cute, huh? It's amazing how abstract the visual description or visual programs are in the 80s. Like, this is an inchworm. It's just a line moving across the screen, but no, it's an inchworm. The leap of imagination it takes to make old computer graphics interesting is fun for me. I still like retro computer graphics. So we'll just let this run for a minute, and then we'll change the color. It'll be fun to do it in a couple different colors. Okay, let's change the color. So we have to run it again. What color sounds good? How about like a yellow, like a light yellow would be good, or maybe it's a medium yellow. I forget which one is which. Okay, let's end that and run it once more with a different color. Oh, I don't know, how about some sort of one of the red colors? I think 7 is a red, I think. Yep, there we go. Of course, it's only so interesting. There's only so much interestingness you can get out of these old computer programs. But these were really great for learning how to think logically. Again, whether they're useful for modern programming or not, it doesn't really matter. It's beside the point when you're young or when computers were new. It's just a matter of teaching people how to think sequentially. Okay, let's run it again. Same with a different... I don't use gray very often. I tend to veer towards white, but let's use gray, which is color 15. There you go. Gray inchworm moving across the screen with the least interesting color you can have on this system. So you can see how you could use this to come up with a kind of a proto version of what later became known as Snake, right? It's going to get a screenshot, but I don't care about the screenshot of the little gray inchworm, but let's let it go all the way across the screen again. We'll run it a couple more times. I love all the different colors in this system. Okay. You can see when you end the program, it reverts back to the asterisk. The Inchworm is made up of 2 asterisks, both of which have the same foreground and background color. That's why they show up as squares. Clever. Okay, so let's run it again. I don't know what color this time. How about some sort of a blue? I think like 5 is a blue color. Yeah, there we go. Of course, it's the same program again and again. I'm just partly showing off the different colors and partly just being mesmerized by these old computer programs I used to find so fascinating when I was a kid. I still find them fun and interesting. I finally have a real TI-99 4A set up in the other room on a CRT TV, and I want to start doing some content on the original hardware, but I need to get a video capture device that actually works. I had an Elgato video capture device, and I got the video working, but I could not for the life of me get the sound working. So stay tuned. I will figure it out and come up with a way of capturing the video from the real TI. But for now, I'm using the classic 99 emulator to demonstrate these old type-in programs. Okay, let's end this one. Let's run it. Let's at least go through one of every color in the rainbow here. How about, see, we did red, there's not really an orange, yellow. Let's do a green, like a dark green. Okay, let's do it once more. Let's do a black one to end our demo of this type-in program. Yeah, the user's reference guide is really handy because it has a description of how every function of TI Basic works, along with little sample programs right in the margin of the description of every function. And then at the end of the book, there are all these little sample type-in programs to put it together, so to speak. And you see some clever uses of some of these methods and functions inside TI Basic all put together into type-in programs, hopefully as inspiration to create your own programs. Alright everyone, well that is Inchworm, the type-in program from the user's reference guide for the TI-99 4A. I highly recommend, if you're interested in the system at all, download the classic 99 emulator and give it a try. It's an awesome little system, or even better if you can pick up an original TI-99 4A. They made a gazillion of them, so they're remarkably cheap. You can find them very easily, cheaper than other kinds of vintage computers. Alright everyone, I'm going to end this stream and get this uploaded to YouTube, and I may be back with some World of Warcraft a little bit later in the not too distant future. Hope everyone's having a good day. If you're watching this on YouTube, be sure to check out my other TI-99 4A videos on my YouTube channel. And if you... Oh, bye my love! See, I didn't know if you were still watching or if you just had me on mute there. See you soon. Yes, a little over, about an hour and a half. A little over an hour and a half. Can't wait for it to be home. And if you're watching this on Twitch, tune back in for World of Warcraft streams. And I do a combination of retro streaming and World of Warcraft and some programming. Mostly World of Warcraft for modern gaming, but I want to dabble in some other games as well. Oh, here, I don't know how to type in a heart from. I can do an emoji from here. Let's see. Can I figure out how to do a heart? It's amazing how far we've progressed in technology. Okay, I don't see a good red heart. Why don't I see regular hearts? Let's just call it an implied heart. I don't see how to type in a regular heart even with the little emoji selected. Oh, maybe I can find one. Trying. Wow, there's all kinds of emojis, none of which are like standard regular emojis, so I don't know how to find a regular heart. Nope. I see everything but a heart. I'll have to give you a kiss when you get home. That's all there is to it. Alright, everyone have a good day. I'll be back with some World of Warcraft in a bit. And I love you too, my love.